This chart shows the spot price of consumer DDR5 memory, the standard RAM used to run applications in modern computers, between September 2025 and January 2026. In just 4 months, the cost of a basic 32GB memory kit jumped nearly 300%. And if you look at the store listing for a 1TB solid-state drive, or SSD, you will see a similar trend. SSDs are the primary storage drives for your files and operating system, and the exact model that cost $149 a year ago is now sitting at $257. To protect their profit margins against these surging component costs, laptop manufacturers are now severely rolling back their baseline hardware specifications. We are seeing a widespread return to 8GB of RAM for entry-level and mid-range systems, a capacity barely sufficient to run modern operating systems and a web browser simultaneously. For the last 10 years, we grew accustomed to consumer electronics getting faster, cheaper, and more capable with every generation. That cycle has broken. Today, you are paying a premium price for a machine that is objectively worse than the one you could have bought a year ago. This hardware squeeze is hitting the gaming market particularly hard. Major vendors are slashing their RTX 50 series graphics card production by up to 40%. They are canceling specific high-memory GPU models entirely, simply because acquiring the memory chips costs too much to justify selling them to normal consumers. The mobile market is experiencing an identical contraction. Global smartphone shipments are dropping at record rates as brands hike the price of mid-range phones by $100 while actively cutting the baseline storage included in the device. This defies the historical trend of Moore's Law, the observation that the number of transistors on a microchip doubles roughly every 2 years, driving the economies of scale that reliably made digital storage and memory cheaper. This sudden shortage stems from a strategic supply-side contraction, a purposeful, calculated reallocation of fabrication capacity toward massive, enterprise-grade AI infrastructure. Platforms like ChatGPT and Gemini run on thousands of specialized servers working in tandem. Building and operating these artificial intelligence models requires an entirely distinct ecosystem of massive enterprise data centers. Training a trillion-parameter AI encounters a physical bottleneck known as the memory wall. The system is actually limited by how fast data can travel back and forth between the processor and the memory, rather than the raw calculating speed of the processor itself. To break through this wall, the semiconductor industry developed high-bandwidth memory, or HBM. Instead of laying memory chips flat on a circuit board, HBM achieves massive data speeds by physically stacking multiple layers of memory on top of each other, connecting them with microscopic vertical wires called through-silicon vias. However, this vertical architecture triggers a severe mathematical problem known as the Wafer multiplier effect. Manufacturing 1 GB of this advanced HBM requires roughly 3 times the raw silicon footprint as producing 1 GB of standard consumer memory. Because total fabrication capacity is strictly limited, every single silicon wafer allocated to build an HBM stack for an enterprise AI accelerator is a wafer permanently stolen from the supply chain for consumer PCs and smartphones. The production of this critical hardware is controlled by an oligopoly of 3 manufacturers: Samsung, SK Hynix, and Micron. Together, these companies dictate the global allocation of raw silicon. Faced with insatiable demand from cloud computing giants, these 3 companies recognized a massive financial incentive. High-bandwidth memory generates an estimated 5 to 10 times more profit per unit for the manufacturer than the legacy RAM used in standard consumer electronics. They are applying this exact logic to the digital storage market as well. By deliberately cutting their production of NAND flash, the core technology used in solid-state drives, by up to 10%, they are artificially restricting supply to drive retail prices higher. The current squeeze on PC builders is a calculated economic strategy. The oligopoly is intentionally starving the lower-margin consumer market to extract maximum financial returns from the AI boom. If you are waiting for these costs to drop, you will be waiting a long time. Constructing, equipping, and calibrating a new advanced semiconductor fabrication plant requires a lead time of 4 to 5 years before mass production can begin. Leading executives, including the SK Group chairman, warn this structural wafer shortfall will persist until at least 2028 and potentially 2030. This chart highlights the severity of the shift. By the end of 2026, enterprise data centers will effectively consume a staggering 70 extend their life cycles and strictly refuse to purchase downgraded 8GB laptops, as they will quickly fail to handle modern software demands. If you must buy a machine, look for older pre-built desktop systems still sitting on warehouse shelves that locked in component costs in early 2025. Alternatively, the refurbished secondary market offers a reliable way to bypass the current retail markups. Until tens of billions of dollars in new fabrication plants finally come online near the end of the decade, the reality is stark. Every gigabyte of memory fueling the artificial intelligence expansion is directly subtracted from the consumer's wallet.